The National Electrical Code, or NEC, is a comprehensive document that outlines the standards for safe electrical installations. It's crucial to reference the most up-to-date version of the NEC when planning or executing any electrical work. It seems there's a misunderstanding regarding Article 388. As of the latest editions of the NEC, there is no Article 388 dedicated to surface non-metallic raceways. This means you won't find specific securing and supporting requirements within that non-existent article. However, this doesn't mean that surface non-metallic raceways are unregulated. Instead, the requirements for their installation are likely covered in other relevant articles within the NEC. To understand the correct securing and supporting requirements, you need to look at the articles that deal with raceways in general, and potentially those that address specific types of non-metallic raceways if your installation uses a specific kind. The NEC is organized to make it easier to find information, so understanding its structure is key. Articles are grouped into chapters based on the type of electrical system or equipment they address. The first 4 chapters cover general rules, wiring and protection, wiring methods and materials, and equipment for general use, respectively. The remaining chapters cover special occupancies, special equipment, and special conditions, followed by communications systems. When dealing with raceways, Chapter 3, Wiring Methods and Materials, is where you will find relevant information. Within Chapter 3, look for articles that cover specific types of raceways. For example, Article 352 addresses rigid non-metallic conduit, often referred to as RNC. While this is not surface non-metallic raceway, it provides guidelines for non-metallic conduit systems and might offer some insights into acceptable installation practices. Article 386 covers surface metal raceways and Article 387 covers intermediate metal conduit. While these are metal, they might provide some general guidance that is helpful. Surface non-metallic raceways are frequently used for extending circuits in existing buildings or for providing wiring solutions where conduit is difficult to install. They are popular for their ease of installation and flexibility. Common applications include offices, retail spaces, and residential buildings. Surface non-metallic raceways are typically made of PVC or other plastic materials that are resistant to corrosion and provide insulation for the conductors inside. They come in various sizes and shapes to accommodate different wiring needs and aesthetic preferences. When installing surface non-metallic raceways, it's essential to follow the manufacturer's instructions and all applicable NEC requirements. This will ensure a safe and code-compliant installation. Several factors determine the securing and supporting requirements for raceways. Firstly, the type of raceway being used is important. Different types of raceways have different structural properties and require different methods of support. Secondly, the size and weight of the raceway and the conductors it contains is another consideration. Larger and heavier raceways require more robust support systems. Thirdly, the spacing between supports is important. The NEC specifies the maximum allowable spacing between supports for different types of raceways. This spacing is designed to prevent the raceway from sagging or becoming damaged. Fourthly, the type of support being used is also a factor. Supports must be suitable for the type of raceway and the environment in which it is installed. Fifthly, the location of the raceway is important. Raceways installed in wet or corrosive environments require special supports that are resistant to corrosion. The NEC provides tables and guidelines for determining the appropriate securing and supporting methods for different types of raceways. These tables specify the maximum allowable spacing between supports and the types of supports that are permitted. In addition to the general requirements for securing and supporting raceways, there may be specific requirements for surface non-metallic raceways. These requirements may be found in the product standards for the raceway or in the manufacturer's instructions. It's crucial to consult these sources to ensure that the raceway is installed correctly. Some common methods for securing and supporting surface non-metallic raceways include using straps, clamps, and brackets. Straps are typically used to secure the raceway to a wall or ceiling. Clamps are used to support the raceway from above, such as from a ceiling or beam. Brackets are used to support the raceway from below, such as from a floor or wall. The NEC also addresses the issue of expansion and contraction of raceways due to temperature changes. Nonmetallic raceways are particularly susceptible to expansion and contraction, so it's important to allow for this movement when installing them. Expansion joints can be used to accommodate expansion and contraction. These joints allow the raceway to move without putting stress on the supports or connections. When installing surface nonmetallic raceways, it's also important to consider the routing of the raceway. The raceway should be routed in a way that minimizes the risk of damage or accidental contact. It should also be routed in a way that is aesthetically pleasing. The NEC prohibits the installation of raceways in certain locations, such as in hoistways or where they are subject to physical damage. These restrictions are designed to protect the raceway and the conductors it contains. It is essential to consult the NEC for specific requirements related to these situations. In addition to the NEC, local building codes may also have requirements for the installation of surface nonmetallic raceways. These codes may be more restrictive than the NEC, so it's important to be aware of them. It's also important to obtain any necessary permits before starting an electrical installation. Permits ensure that the installation is inspected and meets all applicable codes and standards. When working with electricity, safety is paramount. Always de-energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. Working with electricity can be dangerous, and it's important to take all necessary precautions. Proper grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC has extensive requirements for grounding electrical systems. These requirements specify the size and type of grounding conductors that are required, as well as the methods for connecting grounding conductors to ground. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded. Overcurrent protection is another important safety feature. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices will trip or blow when the current in a circuit exceeds a safe level. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device must be appropriate for the size of the circuit. Using an overcurrent protection device that is too large can create a fire hazard. Arc fault circuit interrupters, or FSIs, are another type of safety device that is designed to protect against electrical fires. FSIs detect arc faults, which are dangerous electrical conditions that can cause fires. When an arc fault is detected, the FSI will trip, interrupting the flow of electricity and preventing a fire. The NEC requires that FSIs be installed in certain locations, such as in bedrooms. Ground fault circuit interrupters, or GFCIs, are another type of safety device that is designed to protect people from electric shock. GFCIs detect ground faults, which occur when electricity leaks to ground. When a ground fault is detected, the GFCI will trip, interrupting the flow of electricity and preventing an electric shock. The NEC requires that GFCIs be installed in certain locations, such as in bathrooms and kitchens. In summary, while Article 388 does not exist in NEC, surface nonmetallic raceways are still subject to the requirements of other relevant articles. It's important to consult the NEC and local building codes to ensure that your installation is safe and code compliant. Remember to always prioritize safety when working with electricity and to hire a licensed electrician if you are not qualified to perform the work yourself. Always refer to the latest edition of the NEC, as codes and standards are updated periodically. Using outdated information can lead to unsafe installations and code violations. When selecting surface nonmetallic raceways, consider the environmental conditions in which they will be installed. Some raceways are designed for indoor use only, while others are suitable for outdoor use. If the raceway will be exposed to sunlight, choose a raceway that is UV resistant. This will prevent the raceway from deteriorating over time. When installing surface non-metallic raceways, pay attention to the details. Make sure that all connections are tight and that the raceway is properly supported. Use appropriate tools and techniques to avoid damaging the raceway or the conductors inside. Before energizing a newly installed circuit, thoroughly inspect the installation to ensure that it is safe and code compliant. Check for any loose connections, damaged wiring, or other potential hazards. If you find any problems, correct them before energizing the circuit. Regular maintenance is also important for ensuring the long-term safety and reliability of electrical installations. Periodically inspect surface non-metallic raceways for any signs of damage or deterioration. Replace any damaged raceways or supports. Retighten any loose connections. By following these guidelines, you can ensure that your surface non-metallic raceway installations are safe, code compliant, and reliable.